Civil engineering has historically been a profession of paper and ink, but that foundation is vanishing. As digital tools automate drafting and design, the industry is facing a difficult question about whether the human role is shrinking alongside the paperwork. The shift is already visible in the daily routine. Software is currently taking over the repetitive, high-volume tasks that once defined entry-level engineering. It can generate first-pass reports, draft standard project notes, and cross-reference technical specifications for errors in a fraction of the time it takes a person. This chart demonstrates the speed of that automated scaling. From a single starting point, the system generates 50 different optimized road alignments. It calculates structural load paths and compares the carbon impact of every single option at a pace that far exceeds human capability. For a design team, this removes hours of manual oversight. The software produces near-instant quantity takeoffs and performs clash detection across the entire model, pinpointing exactly where a proposed foundation will strike an existing underground utility line. If a program can generate these estimates, optimize the layouts, and catch the design conflicts automatically, it raises a logical concern. What is the specific value of the human engineer in this workflow? AI has proven it can master the rules-based digital side of the industry. It handles the logic and the math with total precision, which forces a re-evaluation of what the person on the site is actually there to contribute. Software excels at solving problems within a closed system. However, civil engineering involves a constant negotiation with the physical environment, a place where variables rarely follow a clean, predictable script. Algorithms require clean data and fixed rules to stay accurate. When you provide an AI with a perfect digital environment, it produces a perfect mathematical answer. This drainage model shows digital perfection. Water flows smoothly through uniform pipes. But physical sites are rarely cooperative. Unmapped soil shifts, localized debris enters the intake, and real-world variables interfere. The AI's pristine logic breaks down. This is engineering judgment, looking at an optimized output, comparing it to site chaos, and recognizing hidden physical risks. Because the physical world is too unpredictable for a purely algorithmic approach, the project stays dependent on human observation. AI manages the digital model, but the engineer has to manage the reality of the dirt. Beyond the technical challenges of the site, there is a legal and ethical wall that stops automation in its tracks. Even the most advanced AI cannot legally grant approval for a public project. Civil engineering is tied directly to public safety. Unlike most software-driven industries, a failure in this field can lead to a bridge collapse or a dam breach. With human lives at stake, the responsibility must be held by a person, not a program. This creates a definitive legal bottleneck. If an AI-designed retaining wall fails and causes a fatal accident, an algorithm cannot be held liable in a court of law. This is exactly why the professional sign-off remains the industry's ultimate firewall. When a licensed engineer applies their stamp to a blueprint, they are taking personal, legal responsibility for the safety and viability of that structure. Human beings are required to bear the risk. If a design choice leads to a disaster, the AI suggested it is not a valid legal defense. The professional must be able to explain and justify every decision made. Governments, insurers, and the public all demand this level of accountability. They require a person who can weigh political impacts, costs, and safety concerns, someone who is answerable when things go wrong. AI can propose 1,000 different solutions, but the process always stops at the desk of the professional engineer. Accountability is the irreplaceable human element that the technology cannot replicate. AI is creating a divergence in the engineering career path. The first branch, engineers focused solely on repetitive, manual tasks like basic calculations, will see their roles shrink. The second branch, those using automation to test options and detect risks earlier, will become far more productive. However, this shift introduces a significant long-term risk known as the training dilemma. Junior engineers traditionally developed their judgment by performing repetitive manual work that is now being automated. If firms allow software to handle all of these tasks, they risk losing the supervised practice that transforms a student into a competent professional. To remain valuable, the next generation of engineers must master these digital tools while simultaneously seeking out site experience. Understanding the math in a spreadsheet is no longer enough. They must also understand how materials behave in the field. The future of the profession belongs to those who can bridge the gap between digital speed and physical reality. Success now depends on being the person who can direct the machine, verify its work, and take final responsibility for the result.